In this lesson, you will learn how to solve and graph the solution for compound inequalities. Let's take a look at some notes to better help you understand this concept. Before I explain about compound inequalities, let's review some information about inequalities that you've learned in previous lessons. If you look at the directions at the top, it says to write in words what the inequality says. We will start with the variable first in our sentence, and then we will write three values for x that are solutions for the inequality. So let's take a look at example A. In example A, we read this as x is greater than 5. We know it's a greater than symbol because it points to the right. Less than symbols point to the left. Now, if we want to write this in words, we would say x is any number greater than 5. So x can be an infinite amount of numbers. So to write the solutions, you want to think of any number greater than 5. So your solution could be 6, 7, 8, or any number larger than that. Now let's take a look at example B. Example B, notice the inequality symbol points to the left. When it points to the left, it's called a less than sign. So we read this as x is less than or equal to -2. So we want to write that x is any number less than or equal to -2. So if you think about what that means, x can be any number less than -2, or it could be equal to -2. So -2 is a possible solution, as well as any number less than that, which would be -3, -4, or any number less than that as well. Let's drop down to example C. In example C, notice that the variable is on the right of the inequality this time. Well, you always want the variable on the left. So what we need to do is flip the 3 and the x around, but when we do, we need to flip the inequality symbol as well. Because notice that right now, the directions it's facing, it is pointing to the x. So when it's flipped around, it needs to continue to point to the x. Now we can actually read this as x can be any number less than 3. So let's write x is any number less than 3. So what could be some possible numbers less than 3? Of course, 2 would be a number, 1, 0, and then any other numbers that are also less than 3. What about example D? In the same way, we need to flip this inequality around so that the x, or the variable, is on the left. So when we do, notice the inequality symbol this time is pointing to the -1. So we need to flip the inequality symbol around so it continues to point to the -1. Now we can read the inequality as x is any number greater than -1 or equal to -1. So x is any number greater or equal to -1. So think about any number that is greater than -1 or equal to -1. So obviously -1 is a possible solution, as well as any number greater than -1, which would include 0, 1, or any number greater than that. Now let's take a look at some information on what a compound inequality would look like. A compound inequality is two or more inequalities that are connected by either the words and or the word or. So again, it's two or more inequalities that are connected by the words and or. The next thing is the intersection of inequalities. So sometimes the solutions of two inequalities intersect, which means they have some of the same or all of the same answers. So it says a compound inequality that contains the word, and we're going to put and, is the type of inequality that has an intersection of those inequalities. In this case, this type of compound inequality is true if both inequalities are true. And we'll explain what that means in just a second. If you look at this example below, it shows you x is greater than 6 and x is less than 9. And those can be combined together because they share solutions. When you combine them together, the variable goes in the middle of the two inequalities. Now let me write the two separately above. We have x is greater than 6 and x is less than 9. So what you do is you're going to put your smaller number on the left and your larger number on the right to combine them into one. Then you have to look very carefully at the inequality symbols. Notice that the first one is pointing to the 6. So you want to make sure the inequality points to the 6. For x is less than 9, it's pointing to the x. So when we drop it down, it will also point to the x. So this is what a compound inequality looks like when we use the word and. And this tells us there are solutions that are being shared by both inequalities. If you look at this second example, it says the ages of the students in this class are greater than 12 but less than 16. So written separately, it would look like this. I can use A for ages. So the ages are greater than 12, but also the ages are less than 16. So how do we write that as one inequality, which we call a compound inequality? Recall that the variable will go in the middle. The smaller number will go on the left and the larger on the right. When you're writing your inequality symbol for the A and the 12, look back at the individual inequality and notice the inequality symbol is pointing to the 12. In the second inequality, the symbol is pointing to the A. So this is a compound inequality, which we can read, the ages of the students are greater than 12 or less than 16. So in other words, the ages are between the ages of 12 and 16. Now let's take a look at what a union of inequalities looks like. For a union of inequalities, a compound inequality that contains the word or is considered a union. This type of compound inequality is true if at least one of the inequalities is true. So let's take a look at what this means. In the first example below, it says x is greater than 2 or x is less than or equal to -1. So notice the word or. Now these cannot be combined together into one equality. So let's see a real-life example of what a union of an inequality looks like. It says the low and high temperature each day in November was either less than 40 degrees or greater than 65 degrees. So it was one or the other, but they do not overlap at all, which is why you cannot connect them and write them as one compound inequality. So we will write them as two, using the word or in between. So we'll use a T for temperature. So the temperature was either less than 40 degrees or the temperature was greater than 65 degrees. So because, again, there's no intersection in the solutions, less than 40 and greater than 65 do not share any common solutions, we cannot write them as one compound inequality. It must be written as two, as I did in this problem. Now let's look at some additional examples below. In these examples, we're going to rewrite each compound inequality as two separate inequalities so that we understand what it's saying. Then we're going to graph this information on the number line and write 3 solutions for each inequality, although there may be many more than 3. So in example A, if we were to separate this into 2 inequalities, we know that both inequalities will begin with the x. Now let's start with this part here. We know that the x will go on the left and the -6 on the right. And then look and see where the inequality symbol is pointing. And notice it's pointing to the -6. For the second inequality, the x is less than 1, that is actually, you can write it exactly as you see it because it's already written in the correct order with the variable on the left. Now we can see the 2 separate inequalities. X is greater than -6 and x is less than 1. So think back to when you learned how to graph an inequality on a number line. You used an open or a closed circle. So recall that you use an open circle when you either have a less than or greater than symbol with no line underneath. You used a closed circle when you have the line underneath, showing that your answer could be equal to that number. So when you're making your number line, you need to find the -6 and 1 on the number line, and you're going to create it yourself. So I know that -6 is going to be towards the left of the number line. Then I would find where 0 would be. So 5, 4, 3, 2, 1. Here's 0. And then I would find the 1. So I would at least put 0 and the 2 numbers that you're going to be graphing. Now the first inequality says x is greater than -6. Because the greater than symbol has no line underneath, then x cannot equal -6. And to show that, we're going to use an open circle at -6, which means -6 is not one of the solutions. We will do the same for the 1, except for this time it says less than, but we know the 1 is not included. Now, if x can be greater than the -6 or less than 1, notice the arrows point towards each other. So rather than writing the arrows, you can actually just connect them into one line. That means that all the solutions are between -6 and 1. So if you are wanting to write 3 solutions, what could 3 possible solutions be? Well, -5, -4, -3, all the way up to 0. Those are all possible solutions. Now let's do another example. We'll do example B. So first, let's separate our compound inequality into 2 individual inequalities. Again, we know that x will be on the left of both inequalities. We know that 0 will be on the right of one, and 4 will be on the right in the other. So first, let's start with the x and the 0, and notice the inequality symbol is pointing to the 0. In the second inequality, it's pointing to the x. So our 2 individual inequalities are x is greater than or equal to 0, and the second one, x is less than 4. So you need to put those numbers on the number line. So maybe I choose to put 0 here. Again, it doesn't really matter. In which case, 4 would be here. Now, which of the two, 0 or 4, is included as a solution? Hopefully you chose 0. So 0 would get the closed circle because 0 is one of the solutions. 4 is not because its inequality symbol does not have a line under it. Then if you look at the inequality symbol of the first, it says that x can be greater than or equal to 0. The second says x can be less than 4. So again, because the arrows are pointing in the same direction, just connect them to make one line. Now what are 3 possible solutions? Well, 0 could be a solution, 1, 2, and we might as well just write 3 because those are really the only solutions from 0 and are starting at 0 but less than 4. Let's take a look at some additional examples that contain the word or. In example C, we read the inequality as x is less than 1 or x is greater than 5. Now, since they're already separated into two inequalities, we simply need to graph this and look at the solution. So you need to identify where 0 is, and then 1, and then 5. Now let's look at the first inequality. It's a less than symbol. So notice there's no line underneath, so the 1 is not included, so we will use an open circle. Because it's a less than sign, we will point to the numbers less than 1. For the second inequality, we have a greater than symbol, again with no line under it. So the 5 is also not included in the solution. Because there is a greater than symbol, we will point the arrow to the right, to all the numbers greater than 5. So what would be 3 possible solutions, although there's many? Well, let's pick a number less than 1, so maybe we pick 0. And let's pick 2 numbers greater than 5, so maybe 6 and 7. So those are just 3 of the many solutions for this compound inequality. In example D, we have x is less than or equal to -2, and then x is greater than or equal to 3. So let's put those numbers on the number line. So I'll start with -2, then I'll put in 0, and then I will identify where 3 is. So looking at our first inequality symbol, notice the line underneath the inequality symbol, which tells you that -2 is a possible solution. Therefore, we need to put a closed circle. It's also pointing to the left, so we'll point our arrow to the left, to all the numbers less than -2. For the second inequality, there's also a line under the greater than symbol, telling us that 3 is included as a solution. So let's point our arrow to the right because we have a greater than symbol, pointing to all of the numbers greater than 3. So what are 3 possible solutions? Well, let's pick 2 numbers this time that are less than or equal to -2, so we could include the -2, and then we could also put -3 in there. And then if we want to pick an additional number that's either equal to 3 or greater, we could put 3, and if we want to choose to do a fourth, we could also put 4. So there's 4 possible solutions for this compound inequality. Let's move to the next example. In this next example, notice that there's not just an x between the inequality symbols. There's an x plus 5. However, we need there to be only an x, so we need to isolate the x. When you have a compound inequality that needs to be solved, you're going to solve it as if you were solving 2 equations. So if I were to cover up the left side of our inequality, or even cross it out like this would be one of the equations we would be solving. And notice to solve for x, you would simply subtract 5 from both sides of the equal sign. Now let's erase that and do the same thing on the other side. How would you isolate that? You would also subtract 5. So notice you're doing the same thing in both situations. So in order to do them at the same time, you can simply take the positive 5 and subtract it on both the left side and the right side. And that way you take care of both inequalities at the same time. So this will cancel out the 5 in the middle, isolating the x, which is what you want. The inequality symbols will just drop down, and then you'll need to calculate your left and right side. So on the left, -2 minus 5 is -7. On the right, 4 minus 5 is -1. So that is our compound inequality. Now we need to separate that into 2 separate inequalities to graph. So remember, in both cases, the x will be on the left, and then in the first, we'll have -7 on the right, and the second, we will have -1. Now notice the first inequality is pointing to the to the -7, and the second inequality is pointing to the x. So this is the information that we're going to graph. So let's put -7 on our number line and then find -1. And then also we'll put in 0. So is the negative 7 included as a solution? Hopefully you said no, because there's no line under its inequality symbol. And it says that x is greater than negative 7, so we'll point our arrow to the right. In the second inequality, is the negative 1 included as a solution? Again, hopefully you said yes this time, because of the line underneath the less than symbol. Because the solutions are less than negative 1, we'll point our arrows to the left. And again, because the arrows are pointing towards each other, we will connect it with one line. So all of the solutions will be greater than negative 7 or less than or equal to negative 1. So when you identify three solutions, you could choose negative 6, maybe even negative 3, and you could also choose negative 1 because negative 1 is included as a possible solution. Let's take a look at example F. Example F has an OR, which means there's no intersection of the two solutions of the two inequalities. So you're going to solve each one individually. So when you solve the first inequality for x, you will add 4 to both sides of the equal sign, or excuse me, the inequality sign. You'll drop down the x and drop down the inequality sign. Negative 6 plus 4 is negative 2. Then you'll drop down the word OR. So our first inequality is that x can be any solution that's less than negative 2. For the inequality on the right, in order to solve this, we will divide negative 3. Now recall from a previous lesson that if the number next to the x is negative, you will be flipping the inequality symbol in your answer. So when you write your answer, instead of having a less than symbol, you will put a greater than symbol, only because the number next to the x is negative. On the right side, negative 12 divided by negative 3 is 4. So this is the information that you will graph. So let's find negative 2 and 4 on the number line. So if negative 2 were here would be 0, and this is where 4 would be. So starting with the first inequality, it tells us that x can be any number less than negative 2. So negative 2 is not included, so we will use an open circle. And we will point our arrow to the left, pointing to the numbers less than negative 2. For our second inequality, 4 is not included either, so we will use an open circle and point our arrow to the right. So in the situation where you have an OR between the inequalities for your compound inequality, the arrows should always go in opposite directions and there should be no overlapping of the answers. Now for this, the solutions, if we were to choose three solutions, we could pick numbers less than negative 2, maybe negative 3 and negative 4, and then numbers greater than 4, so maybe 5, and there could be others. Okay, we have two more examples to do. So let's take a look at the next. In example G, again, if we look in the middle, the x is not isolated. So what do you think we would do to isolate the x in this problem? Hopefully you recognize that you have a 2 outside parentheses, which tells you to distribute the 2. So let's drop down the 6 and the less than sign and distribute the 2. So in the middle, we will have 2x minus 2. Then we will drop down less than 10. Now we need to isolate the x in the middle. So remember, whatever you do to both sides of the inequality symbols, both on the left and the right. Now to isolate this x, we would first add the 2. And we're going to do that to both the left and the right side of the inequality symbols. So this narrows us down to just a 2x in the middle. On the left, 6 plus 2 is 8. And on the right, 10 plus 2 is 12. We will now, to finish isolating the x, divide everything by 2. Then you will notice the x will be isolated in the middle. On the left, 8 divided by 2 is 4. And on the right, 12 divided by 2 is 6. So our compound inequality looks like this. This is red, x is greater than 4 and less than 6. If we split this up into two inequalities, this is what it would look like. In the first, we would have the 4, and in the second, we would have the 6. Notice in the first, the inequality symbol is pointing to the 4. In the second inequality, it's pointing to the x. Let's put 0 on our number line and then identify where the 4 and the 6 would be located. In both cases, there are no lines under the inequality symbols, so neither the 4 nor the 6 are included as solutions. X is greater than 4 would point to the right, x is less than 6 would point to the left, and again, since they're pointing in the same, or they're facing each other, you would connect them to make one line. Now the only whole number that would be a solution between 4 and 6 for this one would be 5. Now of course, depending on the situation, fraction answers might be an option. In this last example, this would be an OR compound inequality, so you'll solve each one individually. So for the first inequality, to isolate the x, you would first subtract 2 from both sides of the inequality. So that would leave us with 3x is less than or equal to negative 12. When we finish this, notice the number next to the x is positive, so we will not flip the inequality symbol around. It will remain a less than or equal to symbol. So our first inequality is x is less than or equal to negative 4. Drop down the OR, and then solve the second inequality. In the second one, we would add 1 to both sides as we begin the process of isolating the x. We would then divide by negative 1. Now this time, the number next to the x is negative, so we will need to flip the inequality symbol around, which would leave us with x is greater than negative 2. So this would be our compound inequality solved, and now we need to graph it. So we might put negative 4 here on the number line, negative 2 here, and then 0 would be there. Now, the negative 4 is included as part of the solution, so we're going to put a closed circle, but the negative 2 is not, so that will get an open circle. The first inequality reads x is less than or equal to negative 4, so its arrow will point left to the numbers less than negative 4. The second inequality is x is greater than negative 2, so it will point to the right. And then when you identify 3 solutions, pick a number or 2 less than or equal to negative 4, so maybe negative 4 and negative 5, and then a number that would be greater than negative 2, which would be negative 1. And again, those are only 3 of the many possible solutions for this inequality. And that completes the lesson on compound inequalities.